here in this video we're gonna be having a look on three things. First one, comparative view of Pearson and Spearman correlation. Then we're gonna see how can we use correlation in feature selection when it comes to model building or data science, right? In data science, okay. Then we're gonna understand this statement, cause correlation does not imply the causation. We will understand that as well, okay. Let's start with each one of them one by one, okay. First we're gonna see the comparative look on Pearson and Spearman correlation, right? We will simply see in what situation which one of these two fits well, okay. So here we have this particular data set where we have three variables. Now let's take first pair out of this, which is demand and supply 1, and if you draw a scatter plot on top of this, what you get is both of these two variables are linearly related with each other, okay. Now if you take the second pair where you are taking demand variable and supply 2 variable, and when you draw a scatter plot, what you notice is both of these two variables have monotonous relation. Now we will try to find the Pearson and Spearman correlation in both of the cases, okay. Let's start with the first one. Here we just calculated the Pearson correlation, and what we see, the intensity or degree of relation between both of these two variables is +1, which is very strong. Now if you calculate the Spearman correlation, you're gonna get the same result. So we can conclude then that when both of these two variables or any given two variables are strongly correlated, when two variables have linear relation between both of them, then we can calculate either of these two, but the recommendation is to use Pearson correlation. Let's come to the second example where both of these two variables have monotonous relation, and when you calculate the Pearson correlation, the degree which you get is 0.95, but when you calculate the Spearman correlation, the degree which you get is 1. Apparently we can see that the Spearman correlation in case of monotonous relation, right, is giving the better result, right? When two variables have monotonous relation, then calculating Spearman correlation makes more sense. That gives you the better result. So I just hope that it is clear to you in what scenario which of these two should be used, right? Usually when you have the ranked data, so you should also go with Spearman correlation. Next, I would also like you to note when I say linear relation, so in that case you can take example of demand variable, and when you see the amount of increment in demand is by 5, each of the time it is increasing by 5, and when you notice the same thing in supply 1, you get it's 7, right? Means every time it is increasing by the same unit. So the point over here is when there are two variables and both of them are moving in the same direction or in opposite direction, and amount of movement is same, right? Not with when I say amount of movement is same, that doesn't mean that the amount of movement of supply should be equals to amount of movement in demand, right? What I mean is increasement in demand with the previous month or with the previous entry is same every time. If you notice, every time it is 5, right? And same is happening with supply as well. So when this kind of scenarios occurs, right, or when this kind of scenario happens, we can simply say that they have linear relation. But if you notice for supply 2, this is not the case. So in this case a demand and supply, in this case demand and supply have the monotonous relation, this kind of relation would have, right? But in the case of this one, right, it would have this linear relation, okay? So this is also a way to identify the things. Next we're gonna see how can we use the correlation in feature selection when you are working in data science and you have to make some statistical model. Let's take an example. You have been given 20 variables and basis on which you have to make a model which predicts the sale, right? Now out of those 20, let's consider demand and supply are the two variables, okay? Out of these two, demand and supply, which one you should keep? in your model building, because there are 20 variables, so certainly you have to come up with some more specific list of variables which you must use in your model building, right? So in that scenario, which one of these two should you use and which one should you drop, right? So for that, what you can do is you can find the correlation. So before that, we will just plot them on scatter plot, and we see that both of them have a linear relation, right? And when you calculate the Pearson correlation, it shows you the degree of relation is 1. When you calculate Spearman, then also it shows the degree of relation is 1. But that doesn't make any sense. You don't have to calculate both of these two. You can choose the one which is, of course, basis on this relation. You can, of course, go with Pearson relation. All that you should notice is the degree of relation, which is 1. So whenever you get the degree of relation greater than or equals to plus 9 or minus 9, then it is okay to drop either of these variable. That will not put much impact on the prediction. Okay, that won't have impact on the prediction as in fact. Okay, so this is how we do the feature selection. We use the correlation in feature selection. I just hope that it was clear to you. Next, it says correlation does not imply causation. So this simply means that correlation does, if there are two variables which are strongly correlated with each other, that doesn't mean that one increase or decrease in one variable is causing the increase and decrease in the second variable. Let's understand with the example. Let's say you are a shopkeeper and in your shop you sell both of these two things, which is eggs and woolen cloths both, right? At some point you notice that increase in the sales of eggs, sales of woolen cloth is also increasing. What I mean is, with increase in at the same point, increase in both of these two products are happening, and when you plot a scatter plot on both of these two, what you get is linear relation. And when you calculate where the degree of this relation, what you get is +1. When I say degree of relation, means of course you are calculating the correlation, right? So when you calculate this, what you get is +1. Now, does that mean that the increase in sales of egg causing the increase in sales of woolen cloths? Is it possible that if X sales is increasing, that will cause the sales, the people who is buying the eggs will also buy the woolen cloth? No, not necessarily required, right? X is not causing the increase or decrease in sales of woolen cloth. What is it which is putting the impact? Okay, before I go to that point, I would say, to conclude, we can say that though both of these two variables have very strong relation, but X is not something which is causing the increase in the sale of woolen cloth, and same applies on the woolen cloth as well, right? Increase in sales of woolen cloth is not something which is causing in the increase, which is causing the increase in sales of eggs, right? So this is how we say that correlation does not imply the causation. Here in this case, what could be the main cause? The main cause could be winter season, means fall in temperature is causing the increase in sales of both of these two, right? So here we see this kind of example, and it justifies that correlation does not imply the causation. Here we saw that winter season is something which is causing the increase in the sales of both of these two products. In some other scenarios, it could be possible that winter is not something which is causing the increase in both of these two things. I would highly encourage you to look around yourself and find some examples where both of these two variables are correlated, but one is not causing the movement, the difference in the movement of another variable. Okay. Now here in this video we learned Pearson versus Spearman correlation, then we saw how can we use the correlation in feature selection, and we understood this statement where we say correlation does not imply the causation. I just hope that everything was clear to you and it was easy to understand. Just in case if you have any doubt, put that into the comment section. Until then, happy learning. Thank you very much for watching the video. Wish you